the ratios between the lengths, and any triangle could be, made bigger or smaller, but the ratio between these lengths will always stay the same. That's the whole point of these. And we can use these, so if we know an angle in one of the lengths, that kind of gives an indication of the size, then we can just use that to work out what the unknown lengths would be. And what we're going to learn today is like a more, we had a bit of a play with this yesterday, what we're going to look at today is like a more formal way of approaching this. So the idea is that if we have any triangle that has the same angles, they must also have side lengths that are all in the same ratio. That's the idea of what we're doing here. So and if we know one of those lengths, we should be able to find the other one. So let's look at a couple of examples on this side, please. So the first one, so a simple example of this is we would have, we have a triangle here, we know the angle, so we know what shape the triangle is, and we have one of the lengths, and this is the unknown one we're trying to find. We actually should be able to find any of these two unknowns lengths, but in this case we're being asked to find this one. So with these things, there's always 4 steps we go through, so I want to teach you now the formal way of doing this. There's 4 steps we go through. Does anyone reckon they could have a stab at what step 1 would be? Where might we start? Before we do anything else, what might be a good starting point if we have this? Yeah, so before we want to find which rule it is, so we just start by labelling it. So this is the hypotenuse, this is the adjacent, and this is the opposite. So which one would be the relevant, which one would be the rule that would be the relevant one in this case? If that's the adjacent, we'd be using cos, wouldn't we? So step one would be to select the rule. So this one would be cos theta equals a over h. So the ratio that we're interested in here is this ratio here. So step 1 is label and select rule.
So then that's cos 50 equals
Yeah.
x over.
So that's step 1. Step 2 would be to sub. So we know the rule we're using now. That's a really important one because there is 3 of them. So to actually label them and make sure you're selecting the right one is, and once you've labelled them, it's hopefully easy enough to see. That's a really important starting place because it's easy to mix those up. The second step would be now to substitute. So the second step would be to do what we've done now and just substitute. Step 2, so we'd say cos 50. So we know the ratio is cos 50. That tells us what shape, that cos 50 kind of tells us what shape the triangle is. That tells us what the ratio between these lengths has to be. So cos 50,
50 is the angle.
Yeah, 50 is the angle. Yeah. Cos 50 is actually telling us what the ratio, when that angle is 50, it's telling us what the ratio between that and that length is. 50 is the angle. And we know that ratio is the adjacent over the hypotenuse, which is this. Probably would have been better if we didn't choose the same numbers there, but anyway. So here we've now done substitution. So that's step 2 is to substitute. What do we think? What would be the next? Someone besides Abby, who else? Who reckons they could tell us what the next step might be? We have cos 50, which is the ratio equals x over 50. We want to find what x is. What do you think we might do?
Would you times by 50?
Yeah, times both sides by 50. We want to just rearrange the x's by itself, don't we? So you'd say x equals 50 times cos 50, and if we, so step 1 is to now, so step, that's step 3, I guess, is to solve for x. So that's step 3. So it'd be rearrange. So we rearrange this, and then
wouldn't it not be rearranged? Wouldn't it be times the?
Well, we're rearranging it so that x is by itself. The process might be different. We'll look at this example in a second. It might not necessarily be, like in this case we are timesing both sides by 50. That's how we're rearranging this equation. It might not necessarily always be like that. There might be other things. That's where it can change depending on where this unknown is.
Yeah.
So what's 50 times cos 50, calculator?
50 times cos 50 is 32.14.
32.14 centimetres, thanks. So that means that if we constructed a triangle, what that's just kind of saying that if we had a triangle, we made that angle, this is a right angle, we made that angle 50 metres, this length 50, that length would have to measure it as 32.14. So it's a way of calculating that length rather than having to actually measure it. So it's just, because we can kind of see that only one possible way of drawing that triangle. So we should be able to calculate the missing lengths. Any questions about that process? So step 4 is to, I guess, so that's step 4. So there's 4 steps. Step 4 is now to solve. So we have these steps here. You label and select the rule, you substitute the values in, you would rearrange it, and then you would solve it. That's kind of that's the same 4 steps